Well, hello, everyone. Happy today. Hope you're doing well. So we launch into the skeletal system, looking at bones and joints and all that stuff that holds it together. So bones certainly get the most attention when we think about the skeletal system, but we also are going to spend time looking at the different types of joints that allow the skeleton to move in different ways. Now, between those bones and the joints, we have cartilages, and cartilages can cover the ends of bones to aid with smoother motion. So here we see some cartilaginous pads in the knee joint. And then ligaments. Ligaments stitch bones together. Okay. So again, bones are what we're going to spend the bulk of our time on, but then we have different types of joints that allow different types of movements, and they're held together by different types of connective tissue. Now, if we take the skeletal system, it divides into two portions. There's the axial skeleton and then the appendicular skeleton. The axial skeleton, if you look at it, it's the central part of the body. It's the trunk of the body and the skull. Okay. And the axial skeleton is more oriented toward protection. If you look at it, you're protecting the heart and lungs. The vertebral column is protecting the spinal cord. The skull is protecting the brain and then a lot of sensory structures as well. So the axial skeleton is more about protection of vital structures. The appendicular skeleton, the appendages, they're about movement. So these different portions of the skeleton are built differently to do different things. All right, so what do bones do for us? Well, we have several different functions of bone. The first that we look at is the idea of support. Muscles and organs are attached to the bones. So they're provided support from the skeletal system. Protection, you can imagine sort of hardened bone protecting the skull and preventing sort of crush injuries for organs like your brain. Your brain is about the consistency of oatmeal that's been sitting out. So you need to protect that brain inside of a hardened skull. There's a lot of tensile strength in bone. Tensile strength means that it resists being pulled apart. So bone is really good about handling compression forces and tensile forces. And I guess, again, it's because of this lattice work of calcium ions. Let's see. Bone assists in movement. Muscles attach to bone. And when skeletal muscles contract, they move that bone. So that helps move the body. Your bones are also a bank of calcium ions. You can store calcium ions in bone. And then blood cells are actually produced in tissue that's in bone as well. So we'll get into that more later. All right. If we look at bone, what you think of typically when you look at the outside of bone is what's referred to as compact bone. Compact bone is really dense bone, and it's sort of like the outside smooth layer of bone that you see. Okay. So again, that's like the hardened bone. It's called like cortical bone. So it's the really hard bone on the outside. Now, on the inside of many bones, you'll see what's called spongy bone or trabecular bone. That spongy bone is much more porous and less dense, but what it does, it provides like a network. So rather than having bone be solid all throughout and uniformly dense, it lightens your skeleton substantially to have that spongy bone on the inside. Additionally, all those gaps between the hardened bone provide surface area for other types of tissue. Okay, so it's compact bone on the outside and spongy bone on the inside. If we look at this image here of a long bone, you can see on the outside it's sort of a uniform color and texture. That's the compact bone, and then on the inside is the spongy bone. And you'll notice if you zoom in even further, that's built differently. So we'll talk about that stuff more later. All right, classifications of different categories of bones. Long bones. Long bones are, well, they're longer than they are wide. Structurally, they have epiphyses on either end. So they have heads or epiphyses on the ends. And then in the middle, it's got a shaft. Okay, so shaft with two heads, and it's got hardened, compact bone on the outside. We see that long bones, you find them in the appendicular skeleton. So long bones you typically associate more with movement. Short bones, you find those in a couple areas in the body, in the wrists and in the ankles. Short bones are more squared off, like they're little nubby bones. They don't have any sort of shaft. Okay, so they have compact bone on the outside, but on the inside, they're all spongy bone. So again, short bones, they have some different types of joints between them. We'll talk about that more later. But we find short bones in the wrists and in the ankles. Flat bones. Flat bones, as opposed to the name, I think it's more useful to think of flat bones as being thin and curved. So flat bones are thin and curved, and a lot of times they're involved in stuff related to like protection. Your skull, those are flat bones. They're thin and curved bones. The sternum in your chest, or like the breastbone, sometimes people call it that, that's a thin and curved bone. That's a flat bone. Okay. And then the last category of bone we'll look at, irregular bones. Irregular bones have bumps or processes that make them a little different than other bones, that make them so they're not able to be classified easily. We just call irregular bones bones that don't fit into the other categories. Okay, so that walks us through the first clip. We'll get into the anatomy of long bones in just a moment.